Hello and welcome to this DC Velocity webcast, AMR implementation with the correct tooling. I'm David Maloney, DC Velocity's Group Editorial Director. Thanks for joining us. Today, we will discuss the essential role of top modules in automated mobile robots and how AMRs can enable seamless integration into a production environment. We'll cover what top modules are, how they interact with fixtures and stands, and how to select the right ones for your application. But before we begin our presentation, here are some tips to help you connect and participate in the webcast. Our webcast is designed to be interactive between you and our presenters, so later in the program, we'll have a question and answer session to allow you to ask our presenter questions relevant to the topics that we discussed today. Just type your question into the text box on the console, click the Submit Question button, and you can submit them at any time during the webcast. You don't have to wait to the very end. And we'll get to as many of those questions as we can during our presentation. The slides will advance automatically throughout the event. If slides are not advancing, press the F5 key or Control R on your keyboard to refresh your console. We also recommend you disable your pop-up blockers. And if you're experiencing any technical problems, please visit our webcast help guide by clicking on the help link that's below the media player. Now to begin our presentation, I'm pleased to turn the floor over to Tyler Bridger. He's the North American Sales Manager for AMR at KUKA Robotics. Tyler?
Thanks a lot, David. Appreciate it. Again, appreciate everyone being here today, and we're going to discuss the AMR implementation with the correct tooling. Like David mentioned, we're going to talk about the top modules and how to apply those to your application in the real world. So with that, I will share my screen. Give me 1 second. We'll give that a second or two to load. Hopefully you should see it at this point. So let's get started. So I think before we look at a top module for an AMR, we need to define what is the AMR application. Cases, we can cover that with the handful of questions that are shown here, which is what is the product we are moving? How does the current process look like today? How is the product moved today with forklift, pallet jack, hand truck, things of that nature? What is the future state of the process? And then the question I always like to ask is, if you were to start completely from scratch, how would you improve the process today if you could start over? If you said, hey, I have these couple of hurdles in this process, what would I do to make this 100% what I want it to be in the future? So these are all good questions to ask in the beginning before we define our top module to make sure we're covering our bases. So next slide here is, what is a top module? So this is kind of the overarching question of the day, and hopefully I can bring some color to that. So I like to refer to the top module as the end-of-arm tooling of the AMR. So if you're comparing this to a six-axis robot in most cases, if I plop that on the desk in front of me and I want it to perform a task, yes, the robot can move from point A to point B, but it's not going to be able to interact with the environment and interact with my product without having that end-of-arm tooling. Some examples of that are what I have shown here, which might be suction cups, grippers, maybe even a weld torch, a three-jaw chuck, anything of that nature, something that's manipulating that product. Again, I think that's comparable to the top module of the AMR, in that the AMR can move from point A to point B, but we need that top module, or quote unquote, that end-of-arm tooling, to interact with my application and my product to move it around. So that's what I've noted here in some of these notes, but I think some of the key things that I'd like to touch on is the top module is defined by the product that's being transported. So you oftentimes, like I mentioned in the previous slide, you want to look at, what is my product? How is it being moved? What is it being presented at from the point A location? How do I need to present it to the point B location? And then all of that can help define what it looks like overall. And depending how you define that top module, it can really enable the flexibility and the scalability of that application. Again, going back to my previous slide where we talked about future stating the application and what is the optimal status of this application that I can bring going forward, and you can define that in the top module itself. So on that theme of top modules, this is what the top of most AMRs look like. So most AMRs are an open platform where you can bolt on accessories, which we'll talk about here in a minute. It's an open interface where you can pull power from the AMR, you can have communication to the AMR, you can also tap into the e-stop circuitry of the AMR, If your top module is maybe larger than the body of the AMR itself, you might want to add additional e-stops to make sure that the system is safe. So the top module can e-stop the robot, and then vice versa, the robot can also e-stop the top module. A couple unique things that you'll see on top of here is there is also a 2D barcode scanner, or I should say a QR code scanner. So we can do some load identification as well for that product to make decisions based off of what load we have. One thing that's interesting here, you can see on the left-hand side, you have the AMR. There's two photos there. One is the AMR in the lowered position, and then the one in the top left is the AMR in the lifted position. And this is a good example of how all of the AMRs from KUKA specifically have an integrated lift into them. So we'll look at some applications where we're using only the integrated lift, and then we'll look at some more complex applications where we're adding some more top modules to the top of that lift. Just a brief overview of the portfolio and what you'll see in the market. Most AMRs will be basically a payload capacity and then also a footprint size. So you can see we kind of cover a plethora of different payloads and footprints here. So we go all the way from 3,000 kilograms to 250 kilograms, all of which have an integrated lift in them. The one thing that I will note that we'll see a little bit later in a video is the drive type of the AMR as well will also determine how you design that top module and how the AMR interacts with the environment. And you'll see the 1500P, 600, and 250 all have a differential drive, meaning there's two drive wheels in the middle and then four caster wheels in the corners. And those vehicles tend to want to drive forward and backwards. We can rotate on the spot on the center point of the unit, but the unit wants to drive forward and backwards. Whereas the 3000P is omnidirectional, or as a lot of people like to call it, crab walking, in that it can drive forwards, backwards, sideways, diagonal, and everything in between. And that can unlock some different applications as far as side loading conveyors or doing more complicated joining processes, or even using those AMRs in a tandem mode where we can drive two of them together programmatically linked to follow each other, which again, we'll see a video of here shortly. So let's dive into the first video here and the first use case application. So in this example, we're using a KMP 1500P with the integrated lift. You'll see that there's a large base on top of that as well, which I'll discuss here in a second. But this is kind of the bread and butter of AMRs in that we're driving into a stand using the integrated top module, lifting the product off of that stand and delivering it to the next location or next process. In this case, this was a manufacturing process in which we're swapping some stamped sheet metal parts. And what's nice about this one is as this AMR is leaving with the empty container of goods, the next full container is waiting already behind it on the next AMR. And again, when we're looking at the top module and the tooling, this customer needed a tooling that could accept up to 20 plus different bin sizes and types. So that's why you can see that there's a large plate on top of here to accept those various bin sizes. I think this is a very good example of a very non-complex top module that's able to be very flexible for the application. So oftentimes when people think, okay, I have 5, 10, 15, and in this example, 20 plus bin types, how in the world would I be able to move all of those with one AMR? And I think sometimes you can kind of simplify that down to, if I just put a base plate that's big enough to encapsulate all of those bin types, I can use that larger base plate on the standard AMR and be able to move those. What's nice about this video as well, it's not running in this exact example, but we have two stationary stands on the right-hand side, and then that third stand on the left-hand side is actually a tilt stand. So again, the AMR is delivering to it with the standard top module, but then you can use the stand itself to pivot down and present the parts at roughly a 30 to 45 degree angle for the operators to be able to reach those parts. And all of those are consistent heights across the lines in this facility. So this top module, if we're looking at the left-hand side here, is very good for bins, totes, pallets, crates, boxes, anything that's kind of that square footprint that we're picking up from point A to point B. A couple more examples of a similar idea. In this example, the top module for this customer was actually, again, a very simple one where they had some plywood laying around, so they bolted the plywood to the top of the AMR. That's big enough to encapsulate all of their different pallet types. So again, a very simple solution, but it can show you how flexible it is for the environment. And you'll see here, this company is using these in combination with many dozen forklifts actually, to start to reduce some of that forklift traffic and become more automated. And you'll see this is a very similar example, like I mentioned to the last video, where we're dropping to a stand. In this case, it's a wood pallet as opposed to the plastic bin that we saw in the last example. So you see, as we drop it off, the forklift operator at the dock immediately gets a signal that says, I need to pick that up. So you'll see him come swoop in. This gets scanned by the local team member here, and then the forklift comes in to pick it up. So you can see kind of the seamless handoff there in that application. Again, you can see the top module for this is a simple plywood base, just something that's enough to encapsulate their pallets for the application. This is actually from the same application, but on the front end of the pickup side. So what we just saw was the drop off at the warehouse, but this is picking up from drop off at the dock. This is the pickup from the warehouse. So you can see what we're kind of showing here is keeping those forklifts in the warehouse and the dock area and not having them do those long distance travels in between those areas, which is typically a non-value added task for the forklift. So they get their scans, they get their jobs, they pick it from the warehouse, they drop it to these intermediate stands. Then the AMR is doing that long lot delivery from the intermediate stand to the dock doors to be loaded into the truck. Again, very simple top module in this case, using the lift deck that's integrated onto the AMR, bolting on an additional plate, which in this case was a simple plywood solution, in order for them to be able to lift that product. Couple other different examples of kind of the same idea. On the left-hand side there, you can see we're using the integrated lift just as before, picking it up from stands, delivering to another stand. But in this case, you can see that the product is much larger than the AMR. So I wanted to note that the product is not limited to the size of the AMR. Obviously, we want to pay attention to the center of gravity, the load stability, the overall payload, and things of that nature. But as long as all of those details fall within the spec of the AMR, we can lift those from the stand and deliver them from point A to point B. And then on the right-hand side is a little bit more complicated task in which we're not dropping off into a stand, but we're dropping off into a fixture that then gets rotated around. This is basically a weld table, gets rotated around 180 degrees. The part gets welded and it gets rotated 180 back, and then we pick that finished good off of here. So this is a good example, again, using that lift deck. In this example, we're not lifting from a stand, but we're lifting from a fixture. But just kind of to get the ideas and the juices flowing of, as long as I need to put the product in a location and then pick the product from the location, it doesn't have to be that stationary stand bolted in the ground. It can be a fixture, it can be a cart, it can be a rack, and we'll talk about a couple more of those things as we go through this. So moving to a roller conveyor. So this one is taking advantage of the power, communications, the e-stop circuitry that I mentioned earlier on board, and using all of those and combining that into a full powered roller system. So in this example, the AMR is powering the rollers, it's controlling the rollers, it's docking to this other station and telling those rollers to also turn on to accept the product. And then vice versa on the back end, we would dock to a similar conveyor and the product would roll onto us. So this is very good for end of line for finished goods, specifically in the packaging, bottling industry where there's lots of conveyor and product moving very quickly. We can mate directly to that conveyor, receive that product, and then push it off into its next state, whether that's stretch wrapper or finished good or next step in the process. What's interesting about this, and I like that the video stops right here, is if you could imagine earlier, I talked about the differential drive. So in this AMR example, this AMR is a 1500P, and it wants to drive forwards and backwards. So that's why the conveyor is mounted in this direction in which we're mating to the other conveyor forwards and then reversing backwards. However, if you can imagine the KMP 3000, which is omnidirectional, you could actually rotate this conveyor 90 degrees and we could drive up into the mating conveyor. We could side shift 90 degrees, convey multiple products on, and then side shift off and move to the next one. So it adds that additional layer of flexibility with the 3000 and that omnidirectional driving. Again, this application is really good for, similar to the last application, the bins, totes, pallets, crates, things of that nature. And then, like I mentioned, the stretch wrapper and finished good deliveries as well. I think this is a good time to talk about the fact that we're not limited to exactly this powered roller conveyor. Again, it's an open interface in the AMR. We have the power and the communications and the other things available to mount whatever is necessary for your application. So if you need a larger conveyor, maybe just wider and longer, or you need a dual zone or a quad zone conveyor. All of that can be retrofit to the top of the AMR, and the power can be supplied from the AMR itself. So next we have the AMR rack delivery. So this is similar to the application we looked at earlier, where you go into the stand and you pick the product off of the stand. But in this example, we're actually taking the entire rack or product and stand with us. So this gives you a little bit more flexibility in your environment where you don't have to bolt things rigid to the floor. You can take this entire thing from point A to point B. And this is very good for those box, totes, small pieces, assemblies, and kitting type things where you are taking this from the store or the warehouse and delivering it to the line to be consumed at the line. Now, this is very good in that you have the operator who is typically filling these totes and bins and things at the store location, and then they have to drive 5-10 minutes to that line to make the delivery, and then 5-10 minutes back with the empty to then be replenished. But using the AMR in this example, you can keep that operator at the warehouse doing his filling, keep the other line side operator at the line doing his value-added tasks, while the AMRs are doing that pickup and delivery from point A to point B. Now, the one thing that's not shown in this video, but I do like to touch on, is that this cart is not shown with wheels on it, but we can also do carts on wheels, so that it adds an additional layer of flexibility to it, and that we can drop off a wheeled cart near the line, and then the operator can pull that cart closer to the line to perform his task, or maybe use it to make some sort of interface into the line, and then they can pull that away, put it back towards the aisle, and then the AMR can pick that as a flexible solution. So again, similar to the first example in that we're going into a rack, but in this example, we're taking the whole rack with us. And the top module, in this case, we're using the standard lift on top of the AMR, but it's completely open, the interface, and maybe we need to define an interface plate depending on the cart we're lifting, or if we're lifting multiple different plates, again, adding those different structures on top to encapsulate those different plate sizes. Next is kind of a creative solution here. I mentioned earlier how the KMP 3000P can be both omnidirectional and used in tandem. So this is a very good application where we're moving long lumber. I want to say this is 24-foot long lumber on a wheeled cart. So we're kind of doing several different applications here. We're doing a lifting application, we're doing the tandem application, it's OmniMove, and there's a cart on wheels, and all of that's being manipulated by the AMRs. So you'll see this top module is both one that can be moved by the AMR. It can also be moved by operators for other parts in the process. And then again, having that tandem flexibility gives us the capability to move these long and large loads. So you'll see we pick it up for one process, we omnidirectional travel to the next process, and then we feed this into the assembly line for the parts to be picked. And this solution and these top modules are very good for those heavy payloads, those long payloads, frames, wood, steel, things that are much larger structures throughout the process. We're seeing this more and more too for specifically in the automotive space, doing full frame moving. So AMRs have typically been in the pieces, so moving the kits, the bolts, the small parts, the stamp sheet metal pieces, the small weldments. Now we're moving into how do we move the entire frame, maybe the battery assembly, how are we merging those two different things and moving an entire assembly to the next process. Next example here is what I call process interaction. So everything we've looked at so far is really picking up something at point A and delivering it to point B. But what you can also do with the AMR with its embedded top modules is use them for the application itself. So in this case, the AMR is staying with the product. We are delivering it to a stretch wrapper. The stretch wrapper is doing the wrapping, and then we're going on to that next process. So we're seeing more and more applications where the AMR are becoming part of the process itself, as opposed to being a glue in between different processes. So again, this is one good example of a stretch wrapper. There's other examples where maybe we pull it up to a station and there's some assembly being done. And we're seeing more and more applications now where the AMR itself is becoming the assembly line. So think about, in the olden days with the Model T, moving down the conveyor track and operators doing work on it one by one. But it's not a very flexible solution. We're seeing more applications where we're using the AMR as the conveyor down the assembly line. Specifically with nowadays, we're seeing more and more flexible assembly lines where instead of having one rigid line, you have a lot of different offshoots along that line where you can have different options or different specs or different SKUs altogether that are being produced throughout the assembly line. And the AMR gives you that flexibility to navigate those different kind of spider webs of opportunities to get to that finish line. And with that, I think that is all I had on the top module side of it. I appreciate everyone's time today, and I think we will open it up to some questions.
Great. Thank you. Well done. It is time now to move into the question and answer portion of our presentation. And if you did not yet send in your question, now's the time to do it. Just type it into the console, submit it to us. We'll get to as many of those questions as we can. So here are a couple things that have come in. First of all, how would I control the top module, the tooling, if it were powered?
So yeah, I mentioned this a little bit in the presentation there, but there is available power, which is 48 volts DC. You have the communication directly on the top module, and then you have the additional threaded holes, dowel pin locators, and everything on top to be able to power that top module. So assuming it fits within the power requirements of the unit, we should be able to power most devices directly from the unit itself.
Great. Tyler, can you also add a robot arm on top of the AMR? We saw rollers and other kinds of things, but can a robot arm be added to the top of the AMR?
Yeah, it's a very good question and something I didn't touch on too much in this presentation, but there's also what a lot of people call either a mobile cobot or a mobile manipulator, which, yes, adds an additional layer of flexibility to the unit in which you bolt on a 6-axis or 7th-axis arm on top of the AMR. That is plausible. That uses, again, the power from the AMR itself and the communications directly to that. And it's very good for the applications in which you have long cycle times or complicated pick and drop locations, such as loading, let's say, CNC machines or injection molding machines, or in the lab environment. Those are very good for those applications. They're not necessarily high speed, so you wouldn't want to do it for an application where you're doing 100 parts per minute. But if you're doing something once every couple of minutes and you don't want to have an operator or a stagnant robot waiting there for that process to happen again, you can have the mobile cobot drive the robot to the application, do the process, drive to the next application, do that process, and it adds that flexibility and keeps those lines running. That is a product that is out of the box, a solution from KUKA and some other manufacturers, and it's something that's getting increasingly more interest as the market starts to accept that technology.
Yeah, I don't know that I've ever seen that kind of application, but I'd be interested to see it operate. That sounds very interesting.
Yep.
Next question. And this one's dealing with the power of the AMR. Of course, if it's running around a lot, it has to recharge at some point. So how does the AMR charge, and is there opportunity charging, for example, available with it?
Yeah, so all of the AMRs have a charging station. So we ideally want to be able to pull offline from the process that we're doing. They drive in, they plug themselves into that station, they can get a charge, whether it's for a few minutes or it's during break time or opportunity charging, as you mentioned. The other option that all of our AMRs have is wireless or inductive charging. So depending on the process, maybe if you're waiting at a station for a certain period of time, specifically in that assembly line process that I mentioned earlier, you could actually have wireless charging pads at those stations. So while we're sitting there and the process on top of us, let's say the stretch wrapper or an assembly application is happening, we can be getting a charge. So basically we're getting charged throughout the entire process and we're always getting that opportunity charge. So both options there, conductive, inductive, are all available to be able to charge the units.
Great. You of course have, within a facility, sometimes you have a number of different AMRs doing different kinds of applications. Can you really run a mixed fleet of AMR successfully, and how is that done typically?
Yeah, I think there's two layers to this. So the first one would be a mixed, let's say, KUKA fleet, where we have the 3000, the 1500, the 600, and maybe the 250 running around. Our fleet manager can certainly manage multiple different AMR types, who's doing what tasks are specifically assigned to what AMR type, and we can do that. Then I think there's a deeper answer to this, which is a mixed fleet with multiple different brands of AMRs. And that's plausible as well with VDA 5050. So there's several third-party fleet manager companies out there that are supporting VDA 5050, and KUKA does support that as well. So if you're using a third-party fleet manager that can manage other devices on it, we can comply with that and work together with multiple different vendors in that mixed fleet. So couple different layers to the mixed fleet theory and kind of how people are exploring it, but we're trying to be as open as we can to abide by all of those different protocols.
Right. That makes a lot of sense in the age we live in to be able to have that kind of flexibility.
Yep. Exactly.
Well, I'm sorry to say that is all the time we have today for our question and answer session. If we did not get to your question, go ahead and still send it in. We can have someone follow up with you at a later time. So go ahead and still submit that question, and we'll follow up on those as they can. We also encourage you to go to kuka.com. That's KUKA.com for more information on what we've discussed today. And also check out the resources box that's on your console where we have some goodies stashed there for you, some additional information. You can also download a PDF of the slides that were used in the presentation today. Shortly after this live event, you'll also receive an email reminder. You can access the presentation on demand. You can view it again, or we also encourage you to share it with a colleague. Our thanks again to Tyler. You did a great job on explaining all of the different applications and uses of AMRs, so we really appreciate that. And thanks for a very informative session.
Thanks, guys.
Thank you, Ken. And we'd also like to thank our viewers for being with us. We know that your time is valuable, and we appreciate that you chose to spend part of your day watching this webinar with us today. For all of us at DC Velocity, I'm Dave Maloney. Have a great rest of your day.
Thanks.
Making automation easier